So, welcome to Software Pulse, building Java desktop applications. And in this example, we're going to take a look at adding authentication to your application so that your users can log in. Let's start by taking a look at what we're talking about. I have here a small application called Authenticate, which when I launch, will ask you to provide a username and password. So I won't put anything in to start with, and it will just come up with username or password is not valid, and then I can put in a valid entry, press the OK button, and I've now launched into my application. So that's what we're going to take a look at today, and the main focus of this example is to look at how you take care of your users' passwords in a secure manner. So what we'll do is we'll start by launching our Eclipse development environment. And unlike in previous examples where we follow each line of code, what I'm going to do is load up the complete example and then talk through the parts that I want to cover in this exercise. So I'm going to start by creating a new Java project, which I'll call Authenticate. I've got Java 1.7 on here, so that's what I'm going to use. And what I'm going to do now is I'm going to import my source code, which you can get from the website. So you just go to www.softwarepulse.co.uk and go to the courses tab, and in there you'll be able to see the tutorial on this particular example and download the code. So I'm going to import an archive file because that's how it's been provided. I've put my code here, and I've got this authentication.zip file, which you'll be able to get. In the zip file there is the log4j jar file, the org apache commons codec file, and the SQLite JDBC files in there. I've taken them out of the zip file and just put them separately for ease of use, and you might like to do the same. So press open, and I'm just going to accept all the defaults, make sure I'm going to import it into the Authenticate folder, and that's there. Next I'm going to go to the properties of the project, Java build path, libraries tab, add external jars, and then just add in these 3 jar files I talked about, and press OK. So they're all the components we need. And just to check everything's okay, we should be able to run it. And log in. You'll notice down here in the console it's got building the user tables. If it can't find a database, it will build a database for you, put a table in it and pre-populate it with some values. If we go and have a look at the application file, you can see in the public static main method we've got three users that are added into the database. So if we talk about how we create users, because that will give you an insight into how we then validate a user later on. We make a call to a static method called createUser, which is part of the authenticate class, and we pass it the username and we pass it the password. So if we go and have a look at our authenticate class, and here's our createUser method here. The first thing we do is we check to see whether we can find the user, because if the user is already in the database, we're not going to add them again, because that's essentially our username is our unique key in our database. So if we find a match, then we return false and we don't add it. If we don't find a match, then what we're going to do is we're going to take the password the user has given us and ensure that it has a degree of complexity to it. And the way we do that is by what's called salting it. Salt is just a random set of bytes that you can add to the password, which makes it longer. The longer it is, the harder it is to encrypt, to decrypt using brute force. So we've created a little private method called generate salt, which returns us an integer. It perhaps should have returned us a byte array, but I've done it as an integer here, so that's the way it works. So you call this generate salt, it returns an integer, and it uses the Java Security secure random class to get an instance, and it's using just SHA1 to generate an instance, and we just simply get the next value and return it, which returns us an integer value, and you'll see from the log file what those integer values look like. Each user that is created gets their own salt, so that if somebody uses a brute force attack to break one of the passwords in your password table, they can't then work out what the salt is for all the users and make it easier to brute force attack the others. So we return our salt value to there, and we add the password onto the end of our salt. I could do it the other way around, but I've done it that way. And then I call the hash passwords, and this is where we encrypt the password, our new longer password. So already we're encrypting something that is different from what the user passed us. So what we do here is we get a Java Security message digest. We get an instance of the SHA-256, which is the preferred way of doing things. All the others of a lesser encryption level than this are considered to be compromised. 256 is still considered to be okay at the time this was made. And so you just simply pass in the password and get a digest, and that encrypts it. There's no way of unencrypting it, and you'll see when we do compare the login details how we match it to the password that we've now got as an encrypted value, because I can't unencrypt this now. This value is the value it is. So I get my hash password back, which is the encrypted password and salt value, and I add that into my database table along with my username. So there's my encrypted password, and I add in my salt, because I will need to know what I added onto the password, because the user, when they log in, they won't know what salt value I've used. So I hang on to this, and then when they provide the password, I can add the salt onto it and go through the same process I did to encrypt it the first time for the second time, and then I can do a match with it. So once I've added the user into the database, I can return true, that user's added. So that's how you add in your users, and that's how you use the salt and how you encrypt the information. If we now go over to the validate class, when we've entered a username and password and press the OK button, the validate method is notified of this, and we go to the line here. Then we are going to call the static method in our class called authenticate, and we pass into it, we call a method is valid, a static method is valid, and we pass into it our user ID and our password. So let's go to our authenticate method, and we've got this method that returns a Boolean value. It's a static method, it returns a Boolean value, takes two strings, the user and the password, and obviously returns true or false. And the first thing it does is it says, can I find the user in the database? Okay. If there's no user in the database, then there's no point trying to match the password, so we just return false. If we find a user, then what we will do is we will get the password and the salt. We will then call the compare password method. It's a private method within this class where we pass it the password we were passed when we called this method, the password we got out of the database, and the salt that we got out of the database. And if we look at the compare password, private static method, and it takes a password, it takes two strings that are passwords and a string that is salt. And what it will do is it will add the salt to the password and get a byte array representation of that. It will then call hash password, and this is where we encrypt all the passwords. This is how we encrypt all the passwords. So, and this is the key to the whole thing. We encrypt the password, and then we convert the password we got out of the database into a byte array, and then we call compare bytes. And our compare bytes takes the 2 byte arrays we've passed and it goes through them byte by byte doing a comparison, and it doesn't bother finishing and returning the results until it's compared every single byte. The reason being is if you return as soon as you found a mismatch, people can use the time it takes for the method, the compare bytes method, to return to work out how many bytes there are correct. So it takes this long when the first byte comparison fails, it takes this long when the third byte comparison fails, it takes this long when the 20th byte comparison fails. And they can use that to get an indication of how close they are to getting the password right. Whereas this will compare every byte, even if it fails on the first byte, it will still go through and do all of the bytes, compare them all before it returns a result. And that's to stop people doing timings to work out how close they've got to it. And what we also have is we have a log file that shows us creating each of the files, and it shows here you can see the salt with the password, and then here you can see the value of it after it's been hashed. Okay, obviously this is as an example, as an instructional piece of code, so you wouldn't want to put these things in your log file ever, because the whole idea is you're trying to hide this so that nobody knows, not even you know what the password was that was supplied to you. All you ever could do is you do a comparison against that. And there's another one, and then further down you can see we've pressed the OK button here, so we've got Fred and blogs. We've found Fred in the database, so now we're going to check the password. That's how we've built up the password. Now we've hashed it, and now we're going to do a comparison with that to that, and they match, and therefore we've returned true, and we've fired an action called valid, and our application has been displayed. That's how you go about securely holding a username and password so that you don't know what it is, and so that when somebody enters it, you compare the encrypted version against the encrypted version you hold, and you can use that to build up a basic login for your application. Now this is aimed at a desktop application. Things are slightly different if you're using a client-server architecture or you're using a web-based architecture. But if you're just using a standalone application on a desktop, this is the way you can go about it. And hopefully it's given you a few ideas about how to do something if you are choosing to implement or deciding to implement something yourself.